we have a double replacement reaction here that we have to balance. Okay, so we have BaOH2 and Al2SO43 yields BaSO4 and AlOH3, which again is a double replacement reaction. So first what you want to do is you want to write down all of the elements that you have contained in this part of your reaction, and then, sorry, 1 second, my battery's dying. Sorry about that. Okay. Okay, then you're gonna, next thing to do is give each one of these letters, X, Y, Z, and Q is what I always choose. Or you can use A, B, C, D, E, A, B, C, D, whatever. Okay, then you're going to give each one of these equations. So you have X equals Z, because you have, for BA, because you have X and Z, and there are no subscripts, so X just equals Z. And for O, you have 2X, I'm sorry, I wrote that wrong. 2 is on the outside of that. So that makes you have 2 O's, so it would be 2X plus 12Y equals 4Z plus Q. Okay, because you have 2, 12, 4, and only 1 right there. Okay, so for H, it's 2Q, 2X equals 3Q. Okay, AL is 2Y equals Q, and S is 3Y equals Z. Okay, so if you do that out, X, Y, Z, Q, okay, it would be 3, 1, 3, 2. It would make any of these letters 1. For this, I just happened to choose 1. Okay, so it would be 3, B, A, O, H, 2 plus 1, A, L, 2. You don't necessarily have to write the 1. SO, 4, 3 yields 3 BaSO 4s plus 2 AlOH 3s. And that is our balanced equation. Next, what we have to do is we are given a mixture that it contains 32.4% carbon, 8.16% hydrogen, 21.58% oxygen, and 37.85% silicon. And what we have to do is we have to find the molecular formula for each of those. And before we find the molecular formula, you have to find the empirical formula. And by finding the empirical formula, you have to take a certain mass, so it's easiest to make, you're not given the mass, so it's easier just to make it 100 grams. You could just make it up, okay? So you have 100 grams of this mixture that contains this percentage of each. So carbon would be 32.40, hydrogen would be 8.16, oxygen would be 21.58, and silicon would be 37.85. Okay, so that's how much in mass you would equal, that you would have of each of these to equal 100 grams. Okay, so what you're going to do next is you're going to divide each of these by their molar masses. So carbon would be divided by 12.01, which would equal 2.70. A hydrogen would be divided by 1.01, which would equal 8.08. Oxygen, same, which would be 16.00, which would equal 1.35, and silicon would be divided by 28.01, which equal 1.35. Okay, what you do next is divide each of these by the smallest amount that you're given. So in this case, both of them would be, everything would be divided by 1.35, even though these two are the same because they are small. 1.35. Okay, so what you get next is carbon is 2, hydrogen is 6, oxygen is 1, and silicon is 1. And if you don't get whole numbers, you cannot leave them as anything except whole numbers. So if you don't get a whole number, you have to multiply it by the lowest number that will get you a whole number. Okay, so your empirical formula is C2H6OSI. You don't have to write the ones. Okay, so what you do next is you take the molar mass of the molecular formula, which will be given to you, and the molar mass of it is 444.96, and you divide it by the molar mass of this, which is 74.09. And then you divide that, and that gets 6. And what this number is multiplied to each of these to get your molecular formula. So your answer is C, not a C, C12H36O6Si6. And there you go.